Hi, I'm Chris from airwindows, and you've been seeing a lot of dithers coming from me lately because we've been focusing on that a little bit. People seem to be interested. There's a lot of discussion going on about dither. I bet you wonder how I come up with some of this stuff, though. Well, with things like not just another dither, the benchmark for dither performance, thank you, that's me doing all kinds of fancy programming and getting stuff exactly right. But TPDF dither, the normal kind, is a different story. And you can get TPDF dither like this, but what if you wanted to build one? Well, this is how I got, firstly, Paul dither. Then this is also a way to do some of the, I've got I did tape dither, and there's a plugin that will do variations on tape dither. But in order to get to double Paul, this is the tool that I built. So I'm sharing it with you. If you would like to build your own custom dither, here's how you do it. TPDF is like this. It would be the equivalent of taking two different noise sources and putting them at full volume. That's how you get this. Now with tape dither, I think I have what, three spaces, something like that. And if you had two different noise sources, it wouldn't matter where they were spaced because they'd both be noise. It would be the same as putting it here. If they're both noise, this is a sort of delay line, and it would be the same as everything. But if we have, say, this, there is Paul dither for you. This plugin is designed to work with this single noise source. Now I could take that single noise source and make it be two channel, but the thing with this is, see how it's flattening out? That's because this noise source is being repeated. Like I could take the noise sources away, put one in here. The behavior is a little odd, I admit. And put one in here. And we have a funny reaction because we have this noise here, and then in phase, the same noise about 10 samples away. And if we let the audio come through, we can hear that it's working as a dither perfectly fine. But it sounds a little funky because this is one noise source going through all these delay taps. So you could have it be up there, or we could space it out a little bit like this. And what makes this different from the one that I made, which lets you do variations on tape dither, is this is designed to work with a Paul dither-like reaction. Namely, you have Paul dither by doing this. One full amplitude sample of the noise, and then as it gets passed along, -1 means that the next sample is inverted. Now here's why this matters. Oh, that's interesting. No dither at all. We'll put that in here in the middle. Now we have our noise source, and it is behaving exactly like Paul dither. But what would happen if we started fooling with more of these? Like, well, we're changing the responsiveness, aren't we? We can manipulate it in this way. We can make it roll off like this, It still has elements of that because we are manipulating what's called an FIR filter. There are 10 taps on this filter, and the audio comes through and starts adding the noise to it differently for each tap. So what you do if you have a high pass and it's just this sort of high pass filter like thing, there's a technique called sync interpolation, meaning that you take audio and apply an FIR filter where the part around the edges ripples. It'll go kind of up and down, both coming in and going out. And that produces a filter with a sharper cutoff. So what we can see here, and this is what I did to make the double pall, if I want this to be steeper and to get rid of more of the low frequencies, I want to exaggerate the steepness by doing that sync interpolation thing. And what that means is this is 1 and this is -1. So I'm going to want to exaggerate it not by pushing it more in this direction. That's flattening it out and causing the mid-range to be louder. No, I'm going to want to go the other direction. And all of a sudden we have this big peak over here, and the background is quieter. Go from Paul dither to a quieter Paul dither. But wait, looks like we have additional taps, don't we? What would happen if we continue to do this sort of oscillation thing? Because we're doing it at the Nyquist frequency. If we're alternating between samples, that is at 22.050 kilohertz at 44.1K. So let's continue that. This is negative, so this would be positive again. And likewise, you can hear that we can exaggerate it real hard if we want to. Like if I just crank this out super aggressively, keep doing it. I can get this so freaky that it's a really exaggerated boost and there are some irregularities in the response, partly because this is not tailing off as smoothly as it might. And that becomes a sort of hyper double pall, triple pall, quadruple pall. Now I didn't choose to do this for double pall. It's pushing a lot of extraneous energy here. It's got some response irregularities, and when we allow music to come in, I feel like it's got maybe the hint of artifacts in there. There's a slight scrunchiness to the background noise that I'm not entirely enthused about. So when making double pall, I decided to sort of tone down this intensity. Like it does the 1 and the -1. Oh, by the way, let me show you something else. See the low frequency bump? We can make that go away by not taking the negative out. This just goes to show us that the way the dithers are being added, it's a slight low frequency offset by virtue of how it's being run. But we have to have this way in order to have the TPDF working. If we don't, we will eventually get into a truncation-like behavior where it starts grunging up. And we just start hearing just hints of truncation in there. But then if we give it the 1 and the -1, Paul dither again, It smooths right out. Might not have heard much there, but that's why I'm making this available, is for experimenting. Do your own double Paul dither. So what I did was go to pretty much half the amplitude. That was pushing it fairly hard. And then every step of the way, I did about half of that again. And so the 1, 2, and 006 or thereabouts. And the same thing for the other side. So we go to around 5 and then around 2, 5. And around 1, 2. And that's how I got double Paul. As you can see, the curve is pretty much exactly what I had for double Paul. The details are not perfectly locked in. And I know that one of the things that I did to tame this bump is sneak some of these guys back. I was doing it by ear and listening to the tonality of the audio in there. But here's the thing. If you have this, you could do all kinds of wild things. For instance, you can call this double mega Paul, where we have a really intense, exaggerated noise because it's being applied like double Paul did, but then we're adding a whole other layer of +1 and -1 here. Basically, we're adding more noise than we need to exaggerate this, and compared to, it's changing the tonality of that already high frequency noise, and you can hear the sound of it changing. You can fool with this part, for instance, and if you use this combination, it's kind of like Paul dither, but it's got a little darker quality to it. Here, let's make it louder. And this orientation of it gets rid of the DC offset issue being created by the noise source. So Paul dither, roughly double Paul. And then funky exaggerated. And you can do any combination of these that you want. Or you can experiment with the question of, does it actually sound better when there's that tiny offset causing the lowest details to send? It's the way that digital audio in truncation works is you can consider 0 to be a value, or you could consider 0 to be a point between two values. If it's a point between two values, then the quietest stuff is always going to oscillate between those two levels, and dither is only going to force it to stay active when that's happening. If you consider it one of the values, you get stuck with a tiny DC offset, as we see in mine. And that means that the dither causes it to go over into the adjacent values. So it's like -1, 0, 1. And when the noise floor is covering 3 values rather than only 2, the noise sounds better. As we can hear doing this. Here is the noise over its 2 values. And then very much into 3 values. This might be another sound that people like. So this is BuildATPDF. This is what I used to make double pol, and because this is how I roll, I'm making it available to you. So if you like this, you can design any kind of roughly TPDF based dither. Mind you, if it doesn't have two noise sources that are equal to 1, it's not necessarily pure TPDF. It's designed so that you can start with a high pass dither like this. There's no two noise sources. It must be the single noise source just going down through this FIR filter. But you start with this. This is pure TPDF high passed, and then just fiddle with it and get behaviors that you like. And I hope you do like it, because this is kind of fun stuff to do. Talk to you later.